Alright, so let's carry on fleshing out the details of our new algorithm. So we said there are two steps now. The first step involves creating this data structure, which will allow us to optimize the second step, that is the search step. This data structure is going to be the data structure over which we will be performing the search. And that search will be a big O of 1. Because the data structure we're going to be using will either be an array or a hash. That data structure, of course, will house the character count. What does that mean? So we are given a string. That string is composed of characters, and this data structure that we're creating right here will be the character count, meaning how many times every single character amongst all the possible characters that we can have appears in the string. So suppose we were limiting our string to the alphabet. So suppose our string could only take characters within the alphabet. So we would have every single index in that array correspond to one character in the alphabet. So let's say this goes A, B, C, so on and so forth until Z. And what we're going to be storing within those cells is basically how many times that character appears in the string. So if our string is A, B, A, and what have you, then this build data structure step would essentially perform the following. It would first look at the first character in the string, realize it's an A, look it up in our new data structure, and increment the cell right here, so they would all start at 0. So all the character counts would start at 0, and increment the corresponding character count to 1. And then move on to the next character. Then we look at this one. This is B. So we would have to look it up in data structure. B is right here. Increment it to 1. Now this is A. So A we incremented once more, and we get 2. And so on and so forth. By the end of this iteration, where you're going to be looking at every single character of the string, you will have the proper character count in that data structure. So this is setting the stage for the second step, and the second step is basically just searching that data structure for a character count with a single count. So for a character, so we're going to be searching within that data structure for a character having an index or a cell value or a character count of 1. What does this mean? It means that it is a non-repeated character. It only appears once in the string. And we're not going to do that for any single character. We're going to be looking for the first non-repeated character. Remember that. This was part of the problem. We're looking for the first non-repeated character. So the way we're going to be doing it is we're going to pass once more over that string. So we're going to go over that string once more, looking at every single character. And we're going to perform a lookup on that data structure. And that lookup will be a big O of 1. Because our index is essentially the character itself. So we'll look at A, perform a lookup, and then realize that A's character count is 2. So this is not something that we want. We move on to the next character, which is B. And then B, we perform a lookup, we realize that its character count is 1, and this is exactly what we want, so we return B as our first non-repeated character from that function. So this is essentially what we're going to be doing. Now let's observe the efficiency of that new algorithm. Building the count data structure involves looking at every single character in the string and incrementing its corresponding count in the data structure. So how many steps does that involve? It involves exactly n steps, because if we had n characters in the string, we would have to perform that for loop, or that for loop would consist of n steps going over every single character. Now how many steps does the search step right here involve? Well, basically when you're going to be searching, you're going to be looking at every single element in the string, and you're going to be looking up its corresponding character count. So in the worst case scenario, you would have a string with characters, all of which do not appear once, appear more than once. So you'd be looking for every single character, and you will never find one result, so you would have to do n steps. You're performing lookups over every single character in the string, and this would involve in the worst case scenario step. So in total we have in the worst case scenario 2n, and this of course is an operation that costs big O of n. Now you notice how we went from a big O of n squared to big O of n. That was our original algorithm, and this is our current algorithm. Now, which is better, to use a hash and array? We will see that in the implementation in the code.